Okay, keep reading. Refraction. Refraction of light. Okay. Refraction is easy because you already done refraction ka about lenses, वगैरह, all those things. So before starting the refraction, we have to know all the what is refraction क्या है बोल के. So tell me what is refraction means? Refraction means it is bending of light, right? Bending of light when it travels from one medium to another medium. लिखो. It is a bending of light when passes obliquely from one transparent medium to another due to change its speed. Because of change its speed, it bends. Okay. That phenomenon ko we call as refraction of light. So when it passes from one medium to other medium, it bends either towards normal or away from normal. We will see this angle of incidence, this angle of refraction. Is bending of phenomenon ko we call as refraction. Okay. So now optical density. Optical density. See, what is the meaning of optical density? Optical density of a medium is a measure of how much the medium slows down the speed of light passing through it. When it passes through that medium, based on the optical density, how much the speed of light is decreasing, वो पता चलेगा. And optical density is indirectly we will measure through a refractive index only. Okay, optical density means a measure of how much the medium slows down the speed of light passing through it. That means a medium is said to be optical denser if the speed of light is less. Speed of less हो गया तो we say that is denser medium. And optically rarer कब बोलेगा? When the speed of light is more. That is called optically rarer medium. So we have two types of medium. One is rarer medium, one is denser medium. Okay. Denser means particles are closer. उसमें से speed of light will be always lesser. Rarer means particles are दूर दूर में रहेगा. Speed of light is more. So before loss of refraction में आपको Snell's law बोल के आएगा. Before Snell's law आपको थोड़ा refractive index के बारे में learn करके then we'll go for Snell's law. कब? Yeah. Next. Optical density is measured by a term called refractive index, which is density, which is denser, which is rarer बोल के कैसे पता चलेगा? By using refractive index. So we have two types of refractive index. One is absolute refractive index, दूसरा relative refractive index. So what is absolute refractive index? It is a ratio of speed of light in air to the speed of light in medium, air or vacuum, and the speed of light in medium. We represent absolute refractive index as mu. Okay, mu m, and the refractive index of that medium is always equal to c by v. C is the speed of light in air to the speed of light in that medium. Medium ko vm. So that we can understand speed of light in air. This is the definition of absolute refractive index. So लिखो, absolute refractive index is mu m is equal to c by vm. Speed of light in air speed of light in that medium. This is called absolute refractive index. When first surface is speed of light, we can say absolute refractive index defined as speed of light in that medium to the speed of light in that A to the speed of light in that medium. And if you see carefully, refractive index is inversely proportional to the speed of light in that medium. So more the refractive index, lesser the speed of light, and that's called denser medium, right? Inverse relation. Refractive index of air is how much? Refractive index of, suppose मान लो air only, medium is air, so it is, what is the formula? C by the speed of that medium. Speed of that medium is also is air, right? Is 1. Refractive index of air is 1. I say anything you can find. Refractive index of water is 1.33 ऐसा रहेगा. Okay. Refractive index का symbol है mu. Okay. चलो. Now करो. Refractive index of glass is this much with respect to air. मतलब first medium is air. Find the speed of light in glass. मतलब VG is telling to find. So since one medium is air, we can define refractive index of that medium is equal to C by speed of light in that medium. He's telling to find speed of light in this medium. Fine, go. And speed of light in air, you know, right? 3 into 10 power of 8. 3 into 10 power of 8.
2 into 10 power 8.
Yes. 2 into 10 power of 8 meters per second is the answer. So Vm is equal to 3 into 10 power of 8 by mu m is 1.5. So 2 into 10 power of 8 meter per second. Okay. Next. Bending of light. You know, refraction mein bending of light will take place. When it passes from rarer to denser, what will happen? Rare to denser.
Bends towards the normal.
Towards normal. Okay. So light bends towards the normal when it goes from rarer to denser medium. So suppose rarer medium, denser medium. इसका refractive index है mu1, इसका refractive index है mu2. So when a light ray travels from red to denser, it bends towards normal. This is angle of incidence, angle of refraction. Same way, if the speed of light is passing from denser to rarer, it bends away from normal. Bends away from normal. Right. Denser to rarer. So how to remember? You can remember like FAST. Shortcut to remember. F is faster, away, slower, towards. So when light is entering from denser to rarer, speed of light क्या होगा? Speed of light is faster. Speed of light is becoming faster. This principle we have to apply after refraction only. After refraction, we have to apply. So after refraction, the speed of light is becoming faster. Faster is away. So away from normal. So after refraction, the speed of light is becoming slower. Slower is towards normal. So fast remember करने का, faster away, slower towards. Shortcut to remember. Away ना towards है, confused नहीं होने के लिए I told. Then okay. That formula. These all things you done in 10th. Two cases where light does not bend. Tell me any case where light does not bend.
When it travels along the normal.
Okay, next. One more. Normal instance बोलते हैं उसको.
Total internal reflection.
No, total reflection क्या हो कुछ नहीं.
So when they have the same density.
Yes, very good. Super. Okay. Sir, obviously, sir, cheating measure, sir. Okay. So this is angle of incidence is equal to 0. Angle of refraction is also 0. It is called normal incidence. Normal के तरफ अगर मैं incident करूँगा, so it will go straight only. Okay. And one refractive index both are same means it will go undeviated only. ऐसा जाएगा. If mu1, mu2 are same. So first surface is air. We have to refine refractive index as speed of light in air to the speed of light in medium. If the first surface is not air, suppose light is entering from water to glass, like that कुछ enter हो रहा है. So at that time we should define the relative refractive index. Relative refractive index. Okay. So relative refractive index means the ratio of speed of light in the first medium to the speed of light in the second medium is called as relative refractive index. Always we are comparing second medium with respect to first medium. So mu21 is equal to nothing but mu2 by v1, that is equal to v1 by v2. The ratio of speed of light in first medium to the speed of light in second medium is called as relative refractive index. So mu2 by v1. How to write this one? Refractive index of second medium with respect to first medium. Okay. Suppose मान लो they want refractive index of glass with respect to water. So outright refractive index of glass with respect to water is equal to क्या होगा? इधर जो भी फर्स्ट है वो फर्स्ट आएगा, रिफ्रैक्टिव इंडेक्स सेकंड में आएगा. ओके. सो म्यू जी बाई म्यू डब्ल्यू दैट इज इक्वल टू v1 by v2. फर्स्ट मीडियम बाई सेकंड मीडियम का स्पीड ऑफ लाइट. सपोज मान लो रिफ्रैक्टिव इंडेक्स ऑफ डायमंड विथ रिस्पेक्ट टू ग्लास. सो डायमंड विथ रिस्पेक्ट टू ग्लास सो इज इक्वल टू म्यू ऑफ डायमंड बाई म्यू ऑफ ग्लास इज इक्वल टू v1 by v2. सो इनवर्स रिलेशन है. ये सेकंड मीडियम है तो फर्स्ट स्पीड ऑफ लाइट आएगा, फर्स्ट है तो सेकंड आएगा. इनवर्स रिलेशन स्पीड ऑफ दिस कॉल्ड रिलेटिव रिफ्रैक्टिव इंडेक्स. Some books they'll put like this: refractive index of second medium with respect to first medium. All are the same. Yeah, understood formula. Relative refractive index. Chalo. One more thing. Relative refractive index in terms of wavelength. Wavelength. Tell me which parameter will be constant when the light is entering from one medium to other medium. Suppose light is entering, some bending will take place either towards or away. इसका speed मान लो v1, इसका speed lambda, इसका wavelength lambda1, इसका frequency f1 and v2 lambda2 f2. So which parameter will be constant when it light enters from one medium to other medium?
Frequency.
Frequency only depends on source. Okay, it does not change. Or point लिख लो. Frequency depends only on source and do not change in refraction. Frequency do not change in refraction. So you know mu21 is equal to mu2 by mu1 is equal to v1 by v2, right? So what is since frequency is same, I'm putting f and f only. What is speed of light formula? f lambda, f into lambda 1 फर्स्ट मीडियम का, सेकंड मीडियम का f into lambda 2. सो f कैंसिल, देयरफॉर आपको रिमेंबर करने का μ21 is equal to μ2 by μ1 is equal to v1 by v2 is equal to lambda 1 by lambda 2. देखो स्पीड स्पीड का 1 1 आएगा, स्पीड एंड वेवलेंथ का डायरेक्ट रिलेशन 1 1 आएगा, ये रिफ्रैक्टिव इंडेक्स तो इनवर्स रिलेशन है स्पीड ऑफ लाइट का एंड वेवलेंथ का, ये 1 1 2 2, ये 2 1 1 2. Whenever they ask particularly I want only refractive index of this object means with respect to air say comparison always, with respect to air say, whenever they only mention light is entering from one medium to the other medium, he will ask refractive index of second medium with respect to first medium means you have to use this one formula v2 1. Okay, चलो क्वेश्चंस करेंगे अभी. चलो. The speed of light in water and glass are given to you. Find the absolute refractive index of water and glass. Okay. So he's asking separately. Refractive index of water is how much? Absolute refractive index. Absolute index of glass is how much? Which you can use as C by medium speed of that in that medium. C by speed of light in that glass. In decimal, two decimals below.
One point three three into 10 power 8 and 1.5 into 10 power 8.
10 power of 8 cancel हो जाएगा ना?
Yes, 1.33 and 1.5.
Yes. And he's asking refractive index of glass with respect to water also. Refractive index of glass with respect to water.
One point one two five.
Yes, 1.125. Okay. Refractive index of glass by refractive index of water. So this जो भी value है, this by this क्या तो we'll get as 1.125. And refractive index has no units, right? Because दोनों speed of light है ना, so cancel हो जाएगा. चलो. Now this is the IIT question. चलो. Light of wavelength 6,000 angstroms in air enters a medium of refractive index 1.5. Air ये ऊपर air है, they enter into the medium of refractive index 1.5. What will be the frequency and wavelength of light in that medium? So this air medium. तो इस मीडियम में आपको वेवलेंथ चाहिए एंड फ्रीक्वेंसी चाहिए. फ्रीक्वेंसी इन दैट मीडियम इज हाउ मच?
Frequency is 2.2 into 10 power 14.
नो, लैम्डा तो आ गया ना?
9000 into 10 power minus 10.
नो. So I want a wavelength of that light in the medium. Medium में चाहिए. इसका lambda m. Lambda air they given as 6000 angstroms. So you know the formula, right? If first medium, second medium. Refractive index of second medium, which is first is equal to mu2 by mu1 is equal to v1 by v2 is equal to lambda 1 by lambda 2. So this first medium में speed of light तो नहीं दिया ना आपको, ये refractive index सब given to you, यूज करो. एयर का refractive index is 1. now find lambda 2 find करो. so lambda mu2 is 1.5 by mu1 is 1 is equal to lambda 1 is 6000 by lambda 2. so lambda 2 is equal to 6000 by 1.5. so कितना होगा? angstrom is 10 power of minus 10, right? so into 10 करो. it is 6000 by 15. 15 4 is 60. So it is 4000 angstroms you got. This is a lambda 2. Second lambda. Now frequency is the one where we point है. Frequency, you know frequency is same for both, right? इसका F है. F है. So I can write like this. Frequency in air is equal to frequency in medium. You're asking what? Frequency of that medium is asking, right? Okay, since both are same, instead of medium ka, I can use air ka. Air ka frequency, how to find? We know this air mein speed of light is c only. C equal f lambda is the formula. C equal f lambda, right? Speed of light is v equal f lambda, right? Air hai na, that's why c equal f lambda. F is equal to c by lambda. So iska c by lambda. Lambda of air only. So speed of light is 3 into 10 power of 8 by lambda of air, because air ka we are trying to find. Uska only we should take 6000 into 10 power of minus 10. No solve करो, कितना होगा? Two thousand. So 10 power of 18. 3 है ना, 10 cube, 10 power of 21. So 0.5 into 10 power of 21, right? 18, 10 cube, 10 power of minus 18 minus 3 is how much? 5, 15, right? So hertz. So 0.5 into 10 power of 15 hertz is the answer. This is a frequency in air, which is exactly equal to frequency of the medium. Because medium ka we cannot know the c by lambda, v by lambda, speed of light we don't know, right? That's why we are using here ka frequency. So frequency in air is always equal to frequency medium. So a concept use करके also IIT में question came. Okay. So we studied about the refractive index. Refractive index का formula, final formula क्या है? Refractive index of second medium with respect to first medium is equal to mu2 by mu1 is equal to v1 by v2 is equal to c by v is equal to lambda 1 by lambda 2. This is the final formula of refractive index. Okay. Now since we know the refractive index के बारे में we learned, right? Now we will study about the loss of refraction. Loss of refraction. So मालूम है loss of refraction already. The incident ray refracted and normal lies in the same plane, which is same as that of reflection of light. And second law is nothing but Snell's law. Second law is nothing but Snell's law. Snell's law is the heart of the chapter. Every point of time we can use Snell's law. Okay, chala बहुत important है. The ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of medium. This is Snell's law. So what is saying? The ratio of sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given specific pair of medium, for a given pair of medium. And this constant nothing but आगे refractive index बनेगा. Refractive index second medium, it is first medium. Refractive index बोलते हैं इसको. है ना? ओके. नाउ इसका मीनिंग समझो क्या है रिफ्रैक्टिव इंडेक्स. देखो, सपोज मान लो, see they are doing the experiment before. Okay, they took same medium. Okay, so suppose air and water, same medium they took. Okay, and the incident different angles, angle of incidence will be different. I1, I2 and I3, different angle of incidence, the incident light, and the two same color, same medium, same color they took, and the incident definitely based on the angle of incidence, the angle of refraction also will change, right? So it is bending R1, it also bended R2. Based on the angle of incidence, it is bending R3, right? So at the olden times, they want the relation between I and how much it bends. That relationship I want. Suppose if I incident at 60 degrees, how much is bend? 45 or 30 or that calculation के लिए they started calculating. They are using all algebra, A वाला वो वाला they are using. Snell ने क्या किया? He took the help of the trigonometry. He observed in the first case में sin I1 by sin R1 he calculated in the calculator. Similarly, sin I2 by sin R2 he calculated in the calculator. Similarly, sin I3 by sin R3 he calculated. He observed all the values are becoming same. Okay. For a specific pair of medium, for a specific color, the ratio of sine of angle of incidence to the sine of angle of refraction is becoming constant. Okay. And that's why simply he wrote it as sine I by sine R, and that is constant. And that constant is called as refractive index. Refractive index of second medium with respect to first medium, that is equal to mu2 by mu1. Okay. आपको स्नेल्स लॉ पूछेगा तो वी शुड नॉट बाय हार्ट लाइक दिस. आपको बाय हार्ट करने का तरीका विल एक्सप्लेन. जस्ट मल्टीप्लाइड mu1 टू दिस वन, मल्टीप्लाई करो mu1 into sin I is equal to mu2 into sin R. ऐसा बाय हार्ट करो, ऐसा बाय हार्ट करने का. Don't tell whenever they I ask what is the formula for Snell's law, means don't tell sin I by sin R equal to constant. ऐसा नहीं है. mu1 इसका refractive index into the sine of angle of incidence and mu2 into the sine of angle of refraction. So mu1 into sin I is equal to mu2 into sin R. Always you have to follow this one. इससे so many questions will be coming. So what is the formula? Mu1 into sin I is equal to mu2 into sin R. This is the formula. Okay, chalo. Now find angle theta. The light is entering from water to air. Angle is 37 degrees. And refractive index of water also given 4/3. So you know refractive index, you know angle of incidence and angle of refraction we have to find, and air refraction is 1. So use Snell's law and find. Mu1 means incident ka, and incident ka sign of angle of incidence only. So mu1 into sin I is equal to mu2 into sin R.
$53.
Yes, 53 degrees. So mu1 is 4/3 into sin 37 is 3/5 is equal to mu2 into sin R, मतलब sin theta. So 4/3 is nothing but theta is 53 degrees. Okay, mu1 into sin I is equal to mu2 into sin R. Okay, deviation of ray due to refraction. Deviation of ray due to refraction. Suppose मान लो the light is entering from denser to rarer. So क्या होगा? Speed of light becomes faster is away, right? So the light bends away from now. So this is I, this is R. If there is no surface, what would have? The ray would have gone travel straight, right? So because of this different medium, it got deviated. The deviation ko we call as delta. That is called angle of deviation of the ray. Okay, कितना होगा tell me in this case में? देखो, straight line and this line is nothing but angle is what? I. So total angle is R. This angle will be R minus I. R minus I. Or if it is traveling from rare to denser, it will be I minus R. So I'm putting mod R minus I. Okay. So always angle of deviation always by using diagram के you have to solve. Don't by heart like formula. Should solve by using numerical. मतलब problems करके solve करना पड़ेगा. कितना deviation हुआ. अगर एक ही रिफ्रैक्शन हुआ डायरेक्टली यू कैन यूज मॉड आर माइनस आई बोल के और आई माइनस आर. मॉड वैल्यू मीन्स आपको जो भी नेगेटिव है वी हैव टेक द पॉजिटिव वैल्यू. ओके चलो नेक्स्ट न्यूमेरिकल्स करेंगे बेस्ड ऑन द स्नेल्स लॉ एंड इसका बेस में करो. So light is entering from air to some medium. He's asking angle of refraction and angle of deviation.
30 degrees, both.
Angle of deviation is
30 degrees.
30 degrees. Yeah. You're doing a before batting these questions. Okay. So Sriram bolo. mu1 into sin I is equal to mu2 into sin R. mu2 तो मालूम है, sin R we have to find. कितना? mu1 is air into sin 60
So 30.
30 degrees, and angle of deviation is, देखो, it bent towards. अगर ये medium नहीं है तो it would have gone straight. So what is the formula I told you? I mod I minus r or r minus I. So I is 60 minus r, you got 30, right? 60 minus 30 is 30 directly. Okay, ना करो. Find the speed of light in medium A if the speed of light in medium B is c by 3. Okay, and see the speed of light in vacuum, and light refracts from medium A to medium B. So medium A है, this is medium B. Okay, इसका speed of light in the medium is c by 3. इसका speed is c. Okay, and making angle 45 degrees and 60 degrees with the normal. So this is 45, this is 60 degrees with the normal. मतलब it is bending away from normal, right? So bend कर. Okay, he's asking what? Find the speed of light in medium A. A में it is not C, right? Some speed. Okay, because he did not mention first is air, right? Now tell me what is the speed of light in that medium A? In terms of C में आएगा आंसर. Answer in terms of C. Speed of light in A medium I want. VA is how much?
C by 3 root 6.
C by
3 root 6.
3 root 6, no? So light entering from 1 medium to mu1 into sine 45 is 1 by root 2 is equal to mu2 into
Sir, C
sine
by
60.
3, 2 by 3.
कितना?
C by 3, root 2 by 3.
हाँ, correct. Root 3 by 2. So mu1 by mu2 is equal to कितना होगा? Root 3 into root 2. ठीक है, root 3 into root 2 by 2. And in terms of speed of light में क्या होगा? V2 by V1, right? Inverse relation, right? 2 by V1. So V2 is C by 3 by V1 we have to find, which is air only, is equal to root 3 into root 2 by 2. So a 3 नीचे आएगा. So C by 3 VA. So VA is equal to कितना होगा? 2 C by 3 into root 3 into root 2. So कितना होगा? Root 2 by 3. So VA is equal to C by 3. इसको root 2 into root 2, right? Take root 2 cancel. So it is into under root 2 by 3. Answer. Okay. Chalo. Next. A ray of light is incident on a transparent slab of refractive index root 3. If the reflected ray and refracted ray are mutually perpendicular, after incident, reflected ray and refracted ray are mutually perpendicular. In that case, what is the angle of incidence? He's asking, what is the angle of incidence? And this law, when they are mutually perpendicular, this law is called as Brewster's law. ब्रूस्टर्स लॉ. ये आपको वेव ऑप्टिक्स में आएगा. तो The options try. So he's asking find the angle of incidence. Okay. You tell me angle of incidence is equal to angle of reflection. So this is R means this also R. I only. This I means this also I only. Okay. Now you know refractive index of this one and sin I we can find. इसका refractive index मालूम है ना √3 into sin R dash. Okay. So R dash in terms of I में you can bring R dash in terms of I में. If you see carefully, it is a straight line, right? This total angle is how much? 180 degrees. So क्या होगा? I plus 90 plus R dash equal to 180. इसमें is a straight line, right? इस straight line का total angle is how much? 180 degrees. So from this, I want R dash, right? R dash is equal to how much? 90 minus I. R dash, no, substitute Snell's law and solve. And sin 90 minus I is nothing but cos R, cos I.
$60.
Yes. आया 60. Okay. Mu1 into sin I is equal to mu2 into sin R dash. R dash is nothing but sin 90 minus I is nothing but cos I. Okay. Solve. Two boundaries are parallel they given. He's asking find the angle of emergence. E is asking. I by 2, I, 2I, I plus 30 degrees. तो इसको ए आर है ए भी आर है बिकॉज पैरेलल है ना alternate interangles are equal. So separately boundary may apply Snell's law and equate. You will get the answer. Wherever boundary is there, separately you have to apply Snell's law.
So is it just I?
Yes, I know. So mu1 into sin I is equal to इसका मान लो इसका refractive index is mu1 and mu2 and mu1. Solve क्या आ गया आपको भी? Sure क्या? Yeah. Next. Find R, R dash, E and total deviation after two refraction. So each surface में neatly Snell's law apply करना है. Like Snell's law is like A plus B whole square. Everywhere, wherever refractive index, one angle, other refractive index known, we can find by using Snell's law.
So total is 60.
First R, tell me, R is how much?
R is 30.
Yes. And R dash?
So R dash is 60.
No. R dash कितना होगा?
R dash.
R dash I want. See, you got this is 30, right?
Yeah.
You tell me center to circle is that radius, circumference, and center to the circumference is called radius. They both are
So R
equal.
dash is also 30.
So opposite angles are equal, 30 degrees. Now find E. Snell's law,
60.
60 degrees. And angle of deviation is also angle of
Angle
deviation
of deviation. The first surface is 30. Second
हाँ,
one is also 30.
30. So दोनों ऐड करने से कितना होगा totally? Total deviation is 60. That is the answer. So इधर तक पढ़ो, इसका applications देखने वाला है. Next will be the applications. मतलब इसका real depth, apparent depth का, बाद में you have total internal reflection, critical angle का, this lateral displacement, slab का. These all are applications of refractive index. आपको formula sheet open करो.